next we have a recap about potential energy U and force F. So this is just a fundamental relationship in physics. We know force is equals mass times acceleration, so kilograms over meters times seconds squared. And potential energy is measured in joules, which is kilograms, this should be in the top here, meters squared over seconds squared, meaning that to get to the potential energy, we have to add a meter, add a distance, so giving us the relationship of, this is actually kinetic energy. Sorry, U is the opposite of kinetic energy, but Ke equals the integral of F with respect to x, because we're adding in a distance. But essentially force, we know that adding in a meter, Newton meter is joule, is the unit of energy. And we're talking about kinetic energy here when we're doing force over a distance. So we also know that by conservation of energy, the change in kinetic energy is the same thing as the change in potential energy. It's just negative. These two are kind of opposites. So therefore, substituting in U equals negative Ke, we get U equals the negative integral of F dx. Pretty fundamental relationship right here. The negative comes with just kinetic energy being the opposite of potential energy. So yeah, we'll be able to do 29 pretty easily. It's just about the integral and areas under the graph. So yeah, cool. Problem 27, we have a graph of force versus time. It looks like this. It's a constant or linear force like that. And it's pretty much y equals x. This is force in newtons. And this is time in seconds. And it asks us about the change in momentum of the object from time 2 to 4. And the key thing to understand here is that the integral of force is momentum. Integral of F with respect to time equals change in momentum. It's the first line of the physics song, easy to remember. And therefore, the change in momentum from time 2 to 4 is just going to be the integral of force from 2 to 4, which is going to be the area under the curve, or in this case, it's a line of force from 2 to 4. And this is the line y equals x. So we basically have this sort of shape right here where we have 1, 2, 3, 4, 5, 6. The area is 6, meaning that the change in momentum is 6 kilogram meters per second, which is answer D.